Here is a old VCR. The last time I remember working on something like this was somewhere in probably the mid to late 90s. I haven't worked on one since. The problem with this is that it is dead. There's no display on the front of it. And I have done a lot of work with them in the past, but it's been a long time. I know from experience there is a regulator, an STK5481, that does give trouble in them. But also, as far as I remember, there was a resistor somewhere on the power supply that used to give trouble as well. I think it could be a 1 ohm or a 10 ohm. I think it was circuit reference number R1. Okay, we got a overhead shot of the video now, and what I like about these old videos, which we didn't get with the front loaders, the mid-mounted front loaders, was the PCBs on them were mounted on the bottom, and there was no access to test points whatsoever. You might get a little bit of a window somewhere, but it was very hard. If you can see here, you have all the test points that you want on chips. All the circuit reference numbers are printed on the board, and what also I like is you can actually lift these up. I have the screws out already, and there's actually a facility here then for putting this in a service position like that, so we could work on them without any problems. The mid-mounted front loaders just didn't have this ease of serviceability. I could on this now set up the tracking, the head switching point, using test points, no problem, which are probably located on this board here, and that's it. But now let's get back to the problem in hand, which is that the unit is dead. And one of the areas I always like to check first is in here, because it was a fusible resistor that used to always go. It was mounted down here somewhere. Let's see, can I get that board out? I'll just do a quick check. Four screws. Okay. Yes, and just see. Are we getting what we want to see? Okay. All right. Let's do a quick measurement of that resistor. I'm sure it was R1. Okay. And it's this resistor right here. It looks like it was already changed at some point in its life. And yeah, it's reading about 10 ohms, which is about right. That's the only other fault I ever had on these. These didn't have a modern switch mode power supply. They actually had a mains transformer, primary side here, secondary side here, and they give off various voltages. And then there was just a traditional rectifier on this end, smoothing capacitors, and then they went out to this main board. And the regulator is this item here that's mounted on the heatsink, and it's an STK5481, and I'm going to do a little test on that and see what the voltages are out and the input voltages to that regulator. But I most likely but most likely it's going to be that regulator at this stage. Pins 1 to pin 12 of the STK5481 are here on the PCB, and what I'm going to do is first I'm going to just show you the chip. This is all I could get of it now. Pin 2, we're going to go to pin 2 of the IC. We should have 9.4 volts. Now we have 12 volts on that. That's okay, that's an input. This here is a switched 5 volt, so I would expect to see nothing here on pin 3. I got 0.2 on there, and pin 3. Go to pin 4. I got 1.1. Let me just see what we have. On pin 4 I have 1.1 volts output of that switch, so that's also a switch 1 as well. And pin 5, let me see what I have. 0.5 volts, and it's showing 0.2 at that point there. And let's go to pin 6. Pin 6, I'm showing 1.1 volts. That should be 12 volts. That should be there. I should have 12 volts there, because that's coming out of that unswitched regulator there on the that little block. We got pin 7 out. It says bias, but we should have 13 volts there, say, but we have nothing. 8, pin 8. Let's see what we have on pin 8. 2.4 on pin 8. I should have 21 volts coming in there. And I've only got, let me just double check first, make sure. Pin 8. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8. No, I must have went to the wrong pin. Okay, we have our input there, 23 volts, false alarm. I thought it was onto something there. I would have had to go back to that PCB with the transformer mounted onto it if I had nothing there. So it's looking like this 12 volt regulator where pin 7 and 8 connect to the block up above is gone faulty. Right, let's go to pin 9. I don't think we're going to have that on pin 9. Well, we have, yeah, I have 12 volts on pin 9. That's the output of this here. And let's see what 11 has. Pin 12 is 0 volts. Pin 11, let's see what pin 11 has. Pin 11 has 22.79 volts, so that's okay. And pin 10, 13 volts. And pin 9, it should be 13 volts, yes. I'm going to have to say that that regulator is faulty. I am going to have to order one. I know I've looked already online, and the only places I can see is likes of eBay, people supplying them. Some claim to be new. I will have no way of knowing until I get one here and try it and look at, just have a look at the pins, make sure there's no solder on them. I just got to take a chance, because you will not get this chip from a supplier anymore. I wouldn't think so. These videos are fairly old. And even if I do get this up running, that's not the end of the story. I'm looking at the state of the pinch roller and the belts and these. They could have deteriorated as well. And to get pinch rollers and belt kits, It's very difficult nowadays. While it was a simple job years ago, these were bread and butter jobs of the 90s. We made most of our money doing videos. You could get parts readily available from distributors. You didn't have to even go to the manufacturers, order off their sites. You could get them from a distributor, electronics distributor. What I'm going to do here is I'm going to feed 12 volts from a power supply. You can hear it in the background to pin 6 here, which really should bypass that unswitched 12 volt block, and it should send 5 volts into this area here. And I'm just going to see what happens. Find a spot to ground my negative probe and make sure I don't connect to the wrong pin of the IC. You've probably seen a bit of a spark, and I can confirm that it switches on. Oh, and the deck goes in, tries to load, and back out again. Let's see, can I get that on your camera view? Okay, I'll reconnect again to pin 6. Okay, switch is on. It moves in and out by itself, so it's back to life by just feeding the 12 volt line there. I would imagine if this if I can't get an STK5481, I'm going to have to get some kind of a switched 12 volt regulator and see what I can do to modify it, because the only way we're going to get this back up working. And there is a lot of VHS tape out there that people want to copy onto into a media format, MP4, and store it on their hard drives. And the only way you can do it is if you have a working video, which are getting less and less as every year goes by. At least I know I'm on the right track with the regulator. Everything else seems okay. Okay, we're going to start removing this IC from the board. I'm first of all going to freshen up the solder a bit with some fresh leaded solder. It just makes my life easier to remove the IC. Moving the 2 screws, and the IC is out. I wish modern electronics was as easy as this to remove stuff. And there we go. STK5481, that's what it looks like. Okay. And I would say it'll take a bit of work to get this off. Get this. I do have a kind of a spudger. There we go. Yeah. Heatsink compound looks fresh enough. I'll have to clean off that old heatsink compound, and when I get the IC, I will then put it on. I've finally received the STK5481 from eBay, and it's not looking good for a start. This is not normally the way you would get a brand new IC packaged in a piece of cardboard. I'm just going to open it up. And let's see what happens. Okay. What can we say about that? Don't like that. I can see the signs of heatsink compound on it. This is a second-hand part. This is not brand new. Pins are bent. Let me just get it underneath the... let me just view it underneath the microscope to see what solder is on them pins. Let's do a zoom in. Well, that ain't looking good, is it? Unsoldered from a board and sent out as brand new. I've no choice but to give it a try, clean it off, and clean off all this old heatsink compound. They looked like they tried to give it a clean up, but it was not fairly well done. I'll install it and see does it work. But at the end of the day, I don't have much long-term confidence in it that it's going to work. Okay, that's looking like it's enough. Plenty. Get rid of some of the excess. Must get some fresh heatsink compound. This is starting to dry up a bit. Okay. Okay, stick it on. I have to straighten those pins a little bit first and see how it goes. Just solder it in now and see what happens. It'll be a quick job. It'll either work or it won't work. I should have known when I got it off eBay That was not going to be a brand new IC. These are just too old. But we live in hope that someone on eBay is going to be honest. But no, we are where we are. Let me see, plug it in, find a spare socket, and hope that it just doesn't go bang. And the good news is I have a display and it looks like it's working. Let's get a tape and see what happens. I'm just going to put a blank tape in first. You won't be able to see this, but you'll hear it. Well, it's not taking it in, which is a bit of a disappointment. So there is another voltage missing from that. I bet you that 12 volts. Oh no, here we go. It's playing. But looks like there's another problem. Let me just see, is the head spinning? I know you're not going to be able to see this. No movement from the heads. So I have a funny feeling we have another voltage missing off this, the 12 volts for the motors. I've done a few measurements on that replacement STK5481 regulator, and the problem with it was on pins 3 and 4 of the IC. You can see it on the picture here. There was only 1 volt on pin 3 and there was 0 on pin 4. So what I've done, I've taken that out and I've put back in the old regulator, which has just nothing on pin 6, and then there's nothing on these other pins either. So what I found is, measuring the current on this pin 6, I only got about 0.3 amps, 0.4 amps at most in record mode, fast forward. I tried every mode possible and I couldn't get past 0.4 amps coming out of my power supply for that. My only option, as I said earlier, if I couldn't get an IC to replace this, and I believe I probably would have to be very lucky to get one. Most of these ICs on eBay will be second-hand ICs that have been taken off units that have been scrapped for some reason or other. Most likely because this chip is faulty, because it was one of the most commonest faults on them types, on that model of JVC. I'm just going to go here and look on. This is what I found on Radionics or as components. These are like a switching power supply. This here is something like the 78 12s and the 79 12s. Only for these won't get as hot. It's like a switching power supply inside this little module. I haven't done much in circuit design, but I would imagine I'd get away with using this. Have a look down. I'm not going to go through all this data. I might go through it later on. It's a DC to DC converter, as you can see. K78 2000 R3 series. And here's a typical diagram. just looks like a typical diagram of the 7805, 7812s that we would find. But this being a switch and power supply, it's more efficient, and we would already have capacitors on the input on the board, and there's already capacitors here on the output. It says here capacitors C1 and CT must be connected as close as possible. So now that might be a problem, because I'm going to have to mount it somewhere. I don't think I'll have room on the heatsink to mount it. I might be able to glue it in there somewhere, and maybe this won't cause a problem, because it won't get as hot as the those normal regulators. Let's see, refer to table 1 capacitors. C1 and C2, 10 microfarad, 50 volts. Okay, that wouldn't be a problem. I wouldn't think so. I'll order one of these, and I will. I'll just stick it in without those capacitors and see what kind of. I know you can get an oscillating effect sometimes with regulators if you don't put a proper capacitor in there. I'll order up one of these regulators and see what happens. I won't bother putting those capacitors in. If I have an issue, I will. I'll get back to you when I actually get one. It's coming up to Christmas now. Today is the actual 24th of December, so it'll be in the new year before I get back to this. I ordered the little regulator for that JVC video for the STK5481, where the 12 volt line was missing from pin 6, as far as I remember. It's been over a month ago since I looked at it, so while you just have to freshly looking at the video, it's been over a month for me since I was looking at it. I've been busy up to now, but this is, here it is. I got it from Radionics. There's the part number 193-4045, and I'll just open it up and give you a look. And that is what it is. It's a little 3-legged switch mode power supply. It's not a linear regulator like the 7805 the 7812. If you can see it there, 7812 on that, but it actually replaces that. And a switch mode power supply is more efficient. But now, is it going to be more reliable in this application? I don't know. But I can't get an STK5481, so I'm going to wire this in roughly first to see does it work, because it's pointless me trying to find a home for it if it don't work. So that's the first thing I'm going to do. As you see from here, I have this wired in temporarily. Pin 1, which is the input to the regulator, is going to pin 8, which is the 20 something volts input to the SDK. And I have this here is my ground. The blue wire that coming out of that is the ground, and the pin 3 on the right hand side, or the bottom, as you look at the screen, is the output, which is called the pin 6, and that's the 12 volts out. And I'm going to just plug it in and see, do I get a LED, or sorry, the fluorescent lights on the front light up. Okay, I can confirm that we do have lights on the front, and it comes out with standby. I'm just going to stick a tape in it now and see what happens. I know you can't see it, but maybe you can hear it operating. Okay, playing. Don't know what quality of picture it is yet. I'm going to have to get a lead onto it and see what happens. We'll fast forward it. Probably needs a bit of cleaning as well as struggling there to fast forward and rewind. It's a bit slow. But then again, we are used to the more modern versions of this, which really had a fast rewind, which we didn't have back when these videos came out in the first place. But I'm happy that it works, so I've got to find a home for that somewhere that's not going to get too hot. The heatsink is underneath that, and that gets hot, so I can't really mount it there with all that heat rising. And wouldn't last long there. I'm going to have to find some permanent solution. Where, I don't know. That's my next step. I lost all the footage I had on where the final location for this three-legged regulator. What I actually opted for in the end was, if I can zoom in a bit, is this area here. And you can see there's a couple of pins that don't have any PCB going to it. And I just underneath soldered it into these three locations here, and we just see, can I get in further, and ran a couple of wires over it, one to ground, one to the output, the 12 volt output, and then I had the 20 volts input going to into the IC as well. Sorry about losing the footage, but these things happen. Files get corrupted and you can no longer find them anymore. It actually worked. I went back to the customer and they're using it now for copying tapes.